In this video, you will be presented with a .NET out-of-process memory dump of a .NET process consuming too much memory. It is expected that you have already downloaded and opened the appropriate memory dump file in WinDBG, and the MEX extension matching the bitness of the memory dump process is loaded. Analyzing a memory dump in search of the reason for high memory consumption is one of the more challenging scenarios. In many cases, the reason is not discovered using a single command, rather a group of commands. Using the output of these debugging commands can guide you to the root of the problem. Enter and execute the MEX list threads command. This can take a moment, so please be patient. Choose a few of the threads based on the highest execution times, for example, 4, 5, 16, 17, 24. Those threads were chosen because they have been executing in user mode the longest. Switch to each of the threads using the # thread number S and enter the CLR stack 2. Thread 17 has non-Microsoft assembly on the stack. That's clue number 1. Memory is mostly stored on what is called the heap. Enter and execute the dump heap command to view the objects that are consuming the memory in the process. In this scenario, you will receive an error. Ignore that and use the suggested parameter. This will take some time, so please be patient. For extra credit, you can look further to see what is going on with the garbage collection. In the context of .NET memory consumption issues, you will see the existence of garbage collection often. Notice that there are a little over 12,500 system.char arrays consuming 711 megabytes. To drill further into what is contained in those arrays, enter and execute the dump heap on that method table. There were a lot of system.char arrays that were about 16 KB. To filter those out, you can use the min parameter to include only system.char arrays which are greater than 17,000. Now you will see some objects with a larger size of about 102 megabytes. You would want to dump the object details of each of those objects and compare your result. Enter the following command to dump out the contents of that object. The text next to the content is clue number 2, which may be helpful to a developer in determining where this data may be coming from and where in their code it is referenced. Enter this command to find where that object is rooted. This command returns the message showing the assembly, class, and method to which the object is linked. This is clue number 3. It matches the same as from clue number 1. Provide the findings from clue number 1 through 3 to the party owning this assembly and have them investigate the code to determine the actions required to prevent it. Finally, but extremely important, is to recognize that memory dumps contain very sensitive information. Take extreme precautions and follow documented procedures for handling these files. Remove them from all devices once they are no longer needed.